Hey everyone, it's Bradley Bush with another algebra video for you. Today we are talking about factoring sum or difference of cubes. Thanks for coming to my channel. I hope you enjoy it. If you do, please consider subscribing and leave a comment. Give me a like. Here we go. Factoring the sum and difference of cubes. So first you need to know how to recognize the difference of cubes or the sum of cubes. And all we do is look for two terms that are both cubed, and one instance for the difference, you're subtracting the two terms, and the other instance for the sum of cubes, you're adding the two terms. So it would look a little bit like this here that I just boxed out in yellow. So I have a cubed minus b cubed. So a is the first thing that's cubed, and b is the second thing that's cubed, and we're subtracting the two. The second pattern you need to look for is the sum of cubes. So we have a cubed plus b cubed. So something cubed plus something other cubed. And oftentimes when we're doing this, we don't see the cube necessarily. We don't see the exponent, but we can rewrite what we're given to be something cubed. So the two formulas here are one a cubed minus b cubed. So once we have that, we can factor that into a minus b quantity multiplied by the quantity a squared plus ab plus b squared. When we have the sum of cubes, meaning something cubed plus something else cubed, that can factor into a plus b quantity multiplied by a squared minus ab plus b squared. So notice there's a lot of similarities in these two formulas. And I've highlighted the negatives with red to help you tell the difference between them, but everything else is identical. So let's take two quick examples to kind of get our feet wet. If we're given x cubed minus 8 and we're asked to factor that, we would look at it and we would say, well, can we make x cubed into something cubed, and can we make 8 into something cubed? When we look at the x cubed, that one's pretty obvious because it's just x. If we take x and we cube it, then we get x cubed. So that right there is our a. X is our a. What about 8? Well, what about 2? 2 times 2 is 4 times 2 is 8. So 2 then becomes our b. And once we've identified our a and our b, we literally are just plugging them in the formula, which is not terrible, right? I mean, let's do it right now and see. Let's plug in the a everywhere it says a. So we have let's plug in an x everywhere it says a. So we have an x there. We have an x squared here. We have an x there. Now, I'll need a squared on one of those x's. Let's plug in the b. So I have a 2. We have a 2, and we have a 2 squared. Let's finish this off so it actually looks nice. So we have a minus b becomes x minus 2, and our a squared becomes x squared, plus we have a times b, which is 2 times x, or x times 2, and we have b squared, which is 2 squared. Let's rewrite this so it looks a little bit better, and then we'll be done. So if we have x minus 2 in our first term, our first polynomial, and that's multiplied by x squared plus 2x plus 4. And that's it. We're done. So really the biggest thing that you need to do, or the hardest thing I think, is just identifying the a and the b. Once you've identified the a and the b, you're literally just plugging stuff into a formula. So let's do the second one. X cubed plus 8. So we see the plus, we see two terms, and we're like, okay, this has got to be the sum of cubes. And we're thinking, well, can we identify something cubed that equals x cubed? And we can't, because it's just x. And again, we can do 2 for the 8, because 2 cubed equals 8, so that's b. So we found our a and a b, and we can just plug them in. So actually, I'm going to just literally plug them in. Instead of a, I'm going to put x. Instead of a, I'm going to put x. Instead of a, I'm going to put x. And b we said was 2. So let's plug 2 in for b. Erased a little bit more than I wanted to there. And for b, we have a b there that needs to be a 2. And we have a b squared that needs to be 2 squared. Now we can make this a little bit nicer looking, and we have x plus 2. Did I just say nicer looking? Yep, I did. Minus 2x plus 4. And we're done. So it's very similar. We just have negatives in different places. So the sum and difference of cubes really isn't terrible. The hardest thing, I think, is just identifying the a and the b, meaning the two things that you are cubing. Let's find out how this really works in real life with some examples. So I've got 5 quick examples here, and I have the formulas. So we'll just be plugging things in, the formulas as we see them. X cubed minus 27 cubed. Can we rewrite that as something cubed minus something cubed? And yes, we can, because we have x for the a and 3 for the b, because 3 cubed is 27. So there we go. We have our a and our b. So we can literally just write out the answer. And I'm going to do that. We have x minus 3, the a minus the b. A squared is x squared. A times b is 3 times x, so I'll put that here. And then b squared is 3 squared, which is 9. And there we go. Not bad, right? Let's do our next one. As I look at this next one, though, I'm thinking, can I write this in something squared minus or plus something squared? It looks like we have a plus here, so it looks like we're going to have the sum of cubes. But I might have to pull out a greatest common factor first, because I see they both have 2 in common, and they both have a y. They both have the cubed, x cubed, but I think the x cubed might need to stay in there. Let's pull out the y. Let's pull out 2y. And what do we have left? That gives us x cubed plus 27. Now, can we make this into something cubed plus something cubed? And the answer is yes. X is the a, and 3 is the b. And again, we're going to have a 2y hanging out in front. Remember, so we can't forget that. So we have the 2y hanging out front, and we have a plus b, so that's x plus 3. And we have a squared. A is x, so that's x squared, minus a times b, which is 3x, plus b squared, which is 3 squared, which is 9. And we're done. Let's do C. C is 8x to the 4th plus 125x. So we look at it. Do we have anything in common? We should always be taking out the greatest common factor if we can first. And I see, we do. We have an x. Let's pull out an x and see what we have left. That's 8x cubed. That's promising. And then 125, which is also promising because we have an x hanging out. But we can rewrite this as something cubed plus something else cubed. The 8x cubed becomes 2x quantity cubed. So A then is 2x, and we have 5 cubed is 125, so B becomes 5. And remember, we have an x hanging out in front, so we can't forget that. So A plus B is 2x plus 5. A squared is 2x quantity squared, so that's 4x squared. We have minus, and then A times B is 2x times 5, which is 10x, plus B squared, which is 5 squared, which is 25. And we're done. So we just factored the sum of cubes. Let's do D. Looks like we have 2 more left. D is 64x cubed y squared plus 27y squared. Let's take out that y squared. What do we have left? 64x cubed, that's good. And then 27, which is also good, because we can make this into something cubed plus something else cubed. And we just have a y squared hanging out front. 64, that's something cubed, right? That's 4 cubed, so 4 times 4 is 16 times 4 is 64. So 4 cubed, and I need an x. I should probably move that 4 over. So 4x cubed, so A is 4x, and 3 is B. Poor 27 gets used a lot in these problems. So we have a y squared hanging out in front, and A plus B, 4x plus 3, and A squared is 4x quantity squared, which is 16x squared, minus A times B, which is 3 times 4x, which is 12x, and then a plus B squared. B is 3, so 3 squared is 9. And we're done. Last one. We can make this into something squared. Sorry, something cubed minus something cubed. So we're going to use the difference of cubes formula here, and we have x for the A and 4 for the B. That gives us x minus 4 and x squared plus 4x plus 16. And we're done. Hope that was helpful. Thanks for watching, and have a good day.